Okay, so good afternoon to one and all. In the previous lecture, we have discussed regarding equivalent circuit diagram of a single phase transformer. So in equivalent circuit diagram, what is the purpose to draw the equivalent circuit diagram, and what is the importance for driving a equivalent circuit diagram? And we have already seen how to draw the equivalent circuit diagram. That means after equivalent circuit diagram, the transformer may be a single winding transformer, and it will make the calculation simple. So this part we have already discussed in the previous lecture, right? Now today we will discuss about the next one point in a single phase transformer, that is testing of single phase transformer, or it may be testing of transformer. As in the unit 3, we have discussed testing of DC machine. Similarly, some tests we have conducted in case of DC machine. So similar to that, we are conducting some of the tests on single phase transformer. So that is testing of single phase transformer. What is the importance of testing? While doing and testing, we will get some of the data. By interpretation of that data or calibration of that data, we will get the performance of the transformer. We will understood the performance of the transformer. So that the testing, it is important in case of single phase transformer, whether it may be transformer it is okay, or it may be whether the transformer it is well in condition. We will analyze the performance or the condition of the transformer by conducting a test, right? No, yes, getting testing we have already discussed, same in the case of DC machine. So that's why we are conducting test on any equipment like transformer, induction motor, DC generator. We know the performance, we understood the performance. Okay, now see, there are some of the tests is to be carried out on a single phase transformer. So see, in the testing, we are discussing regarding some tests. That is, first one test is nothing but polarity test. Second one test, it is nothing but open circuit test. And third one test, it is nothing but short circuit test. So this test we want to discuss in this unit, that is testing, or in this bit, testing bit, polarity test, open circuit test, and short circuit test. So see, in that first one we will discuss the polarity test. Now see, while performing the transformer, or while operating two or more than two transformer in parallel, so at that time we should understand the polarity of the transformer. That means the same polarity of the first transformer, it can be connected to the same polarity of the second transformer, so that while connecting two or more than two transformer in parallel, so at that situation we should understand the we should understand the polarity of the transformer, whether this terminal having the positive polarity, whether this terminal having a negative polarity of first transformer similar to that of positive negative, so that there is a no mismatch in the connection, or there is a no opposition in the connection. Okay, so that the polarity test, it is important. Polarity test, it is important. See, we do the polarity test on parallel transformer to ensure that we connect the same polarity winding and not the opposite one, right? See, while operating two or more than two transformer in parallel, you should know the polarity, and if once we know the polarity, then we are connecting a same polarity of both transformer or multiple transformer at the same point. Otherwise there is a opposition in the connection, right? So see, if we accidentally connect the opposite polarity of the winding, if we accidentally, or if by forgottenly, or it may be by mistakenly, if we connect the opposite polarity, what will happen? If the opposite polarity can be connected, its result, it will be the short circuit, it will be occur, right? Its result, the short circuit it may be occur and it will damage the machine also. So that the polarity test it is important. Getting? All of you getting why the polarity test it can be conducted? It is very simple. Getting no?
Yes.
Hello? Give me reply. All of you getting why the polarity test or what is the important behind conducting a polarity test? Anyone just give me reply, yes or no?
Yes, sir.
Okay. See, the transformer it is having an suppose the big transformer is there, it is having an costly. So to avoid this damage or result in the short circuit, if the short circuit occurs, there should be a bushing, it may be damaged, or it may be the insulator of that terminal, it can be connected somewhat they damaged, or it may be somewhat winding, it may be damaged. To avoid this condition, we should check the polarity and then do the connection. So it is better method. Now see, this polarity test it can be categorized into two types. First one is nothing but additive polarity, and the second one is nothing but subtractive polarity. Now how we will understand it is additive polarity, how we will understand it is a subtractive polarity. So it is understood by simply conducting or by simply doing a simple connection. So I will show that the figure. Now see here, what is the additive polarity? In additive polarity, that means how the polarity test it can be conducted. See, the transformer it is having an primary winding, transformer it is having an secondary winding. Transformer la primary winding असेल, transformer it is having an secondary winding, right? See, on the primary side there are two terminal, on the secondary side there are two terminal, right? So one terminal or one terminal of the primary and one terminal of the secondary, it can be connected together. Baga, how the test it can be connected. One terminal of the transformer and the one terminal of the first primary winding of the transformer and another one terminal of the secondary winding of the transformer, it can be connected directly or by using a rigid wire, or it is connected or it may be a common one. And remaining two terminal, there are one voltmeter it can be connected, right? See, suppose this is one of the transformer, this is one of the transformer, here it will be shown in this figure. If you are not understanding, then I will draw the diagram. This is the transformer primary winding, this one is the transformer secondary winding. Here it is one terminal, this one is the another one terminal. Similarly, this is next terminal of the secondary winding, here it is next terminal of the secondary winding, right? So these are the four terminal. On the primary side there are two, on the secondary side there are two. See, on this terminal, any two terminals it can be connected directly, or it may be directly connected by using a rigid wire, or directly it can be done common. And on the other side of the terminal, there is one of the voltmeter it can be connected. राहिलेले जे काही दोन टर्मिनल असतील, we are connecting one of the voltmeter, and now we are applying voltage to this two side. Okay, voltage here it is voltage at the primary side, suppose we are representing VA, voltage at secondary side, suppose we are representing VB, right? So voltage at the primary side VA, voltage at the secondary side it is nothing but VB. So the voltmeter VC which are connected in between these two winding, if it will be shows the value, it is the summation of voltage of these two voltages, right? No, that means VC it is equals to VA plus VB. Voltage VC it is the sum of voltage across primary winding and the voltage across secondary winding, then there is a we can call it as a there is a additive polarity, right? No, that means the voltage obtained at the voltmeter which are connected in between these two terminal. So this voltmeter, it will be shows the voltage which is in the sum of these two voltages like VA and VB. Then we can call it as a its additive polarity, right? Additive polarity, that means here it is negative, here it is positive, here it is negative, here it is positive. Suppose we are applying one KCL, so it will be like this: positive VA minus VC positive VB, it is equals to 0. Sorry, we are applying KVL, then VC, it is shifted to the right hand side, so VC is equals to VA plus VB, like this. So if the voltmeter which are connected between remaining two terminal, if it shows the value, it is the summation of the voltage across primary winding and the voltage across secondary winding, then it is called as there should be a additive polarity. Getting? There should be a additive polarity. All of you getting?
Yes, sir.
Okay. So if the voltmeter, it will be shows the summation, and opposite to that, it is nothing but subtractive polarity. याच्या opposite जे असेल, it is nothing but subtractive polarity. See, the similar connection, it can be done for understanding the subtractive polarity. Again, the two terminal of the one terminal of the primary winding and one terminal of the secondary winding, it can be directly connected by using a rigid wire, and remaining two terminal, one of the voltmeter, it can be connected. One of the voltmeter, it can be connected. If the voltmeter connected across these two terminal, if it will be shows the voltage, it is the difference between the voltage across primary winding and the voltage across secondary winding, then there is a subtractive polarity. Getting? So voltage which are occur, that means voltage shown by this voltmeter, it is the difference between these two voltages like VA and VB, then we can call it as a there is a subtractive polarity. See, if we are applying KVL to that loop, या loop ला जर मी KVL apply केला, if we are applying the KVL to that loop like this clockwise direction, so negative to positive is nothing but positive VA, positive VC, positive VA, positive VC, then minus VB, it is equals to 0. So VC, it is equals to VB minus VA, or VC, it is equals to VA minus VB. That means there is a subtractive polarity. There is a subtractive polarity. So see, in subtractive polarity, the voltage between the primary side VA and the secondary side VB will be the difference between of both high voltage and low voltage. That is, we will get VC, it is equals to VA minus VB. So that we are telling it as a subtractive polarity is there, right? There is, we can call it as a subtractive polarity of the transformer is there. And once we have understood the polarity, then we will make the connection, or we will operate the two transformer in parallel. So this is the related to polarity test. It is very simple. Just we want to connect two terminal of the winding common, and other two terminal there is one voltmeter. So simply by conducting such test, we are able to tell additive polarity and subtractive polarity. So voltage occur across voltmeter. If it is addition of these two voltages, then it is additive polarity. If it is a difference between, or it is the subtractive voltage of the top two voltages, then we can call it as a subtractive polarity. Okay, so this is polarity test of a single phase transformer. Single phase transformer polarity. See, in a subtractive polarity, VC is equals to VA minus VB. VC, it is equals to VA minus VB, as I have tell, and also VC is equals to VB minus VA, and it is depends upon whether the transformer is step up or step down. It is in the step down transformer, and if the step up transformer is there, VB minus VA, this formula is there. That means in step up, this VB is greater than VA. That means VB is greater than VA in step up, and in step down, VA is greater than VB. That means it is nothing but step down. So we use additive polarity for small scale distribution transformer and subtractive polarity for large scale distribution transformer. So this is MCQ question. Small scale distribution transformer, we use additive polarity. Large scale distribution transformer, we use subtractive polarity, right? We use a subtractive polarity. Okay. Getting polarity test, all of you? Hello.
Yes, sir.
Yes, sir.
Okay. So this is very simple. Now, the procedure which is to be followed for conducting a polarity test. Similarly, connect the circuit as shown in above. Voltmeter VA across primary winding and secondary winding. Voltmeter VA, it is connected across primary winding. Another voltmeter VB, it can be connected across secondary winding, and another one voltmeter VC, it can be connected in between that two terminal, right? If available, take down the rating of the transformer and turns ratio. If you are having an rating of the transformer, or it may be you are having a turns ratio of the transformer, then note it down. We connect one of the voltmeter VC between primary and secondary winding, and we apply some voltage to the primary side. By checking the value of VC, we can find the whether there is additive polarity or subtractive polarity. So if the VC, it will be shows voltage VC, it is equals to summation of VA plus VB, then additive polarity. And if the voltage shown by the voltmeter VC, it is equals to VA minus VB, it is nothing but subtractive. For step down, for step up, it is equals to VB minus VA, it is again subtract, right? So this is the procedure to carry out polarity test. It is simple, very simple. So here, see here it is connection diagram. It can be given how it can be connected. We are using one of the single phase wire. By varying the supply voltage, here it is one voltmeter is connected across primary, another voltmeter it can be connected across secondary. These two terminal are commonly connected. Remaining two terminal, across remaining two terminal, one of the voltmeter VC, it can be connected, and by observing the value of VC, we are telling that whether there is a additive polarity or whether there is a subtractive polarity. Okay, getting all of you? Connection diagram also?
Yes, sir.
Okay. Now we will discuss the next one test, is that open circuit test of the transformer. Okay, open circuit test, or we can call it as a no load test. Open circuit. So secondary terminal, it is nothing but open circuit. That means the transformer on no load condition, right? Barabar na?
Yes, sir.
So open circuit test, we have already discussed the some parameter when the transformer on no load condition. So this similar parameter, it can be obtained by performing OC test. Which parameter we have discussed? Transformer on no load, we have already discussed. What happened in the transformer on no load? What is to be calculated? काय कॅल्क्युलेट करतो आपण? Okay, let it be. See, the purpose of open circuit test, that is the purpose of open circuit test is to determine the no load losses. We have already discussed in the many times. The purpose of open circuit test is to determine the no load losses and the no load current of the transformer. Okay, or no load equivalent circuit parameter. So we have drawn the equivalent circuit diagram. Which are the no load equivalent circuit parameter? कोणते कोणते आहेत? Which equivalent circuit draw केलं होतं आपण? We want to perform the practical for the same open circuit test and short circuit test. OCSC test practical perform करायचे. Which parameter it can be calculated in the that means in the equivalent circuit we have that means we have shown that parameter, no load parameter. Which are they those? कोणते कोणते होते? No load current I0 again. Speak something.
R01.
Tell, don't be hesitate. So R0, then X0, again we are calculating IW, IMU. Like, so these are the some equivalent circuit parameter. So our aim of practical is nothing but determination of equivalent circuit parameter by conducting OC and SC test. So OC test, depending upon or by conducting OC test, we will get this parameter, that is no load current, R0 that is no load resistance, X0 no load reactance, IW is nothing but working or active component of no load current, IMU is nothing but magnetizing component of no load current. So that means we are calculating no load parameter, calculating a no load parameter. Okay, now see, this test it is performed on the primary winding of the transformer. Okay, that means the secondary side it is open circuited, right? Secondary of the transformer it can be open circuited, secondary of the transformer it can be open circuited, and we are providing supply to the top primary side, and we are conducting this test, that is OC test. See, for the conduction of OC test we required one of the voltmeter, we required one of the ammeter, and we required one of the wattmeter. So these are connected on the primary side. Primary side ला हे equipment आपण काय करतोय, connect करतोय by giving a supply or by providing some of the voltage, rated voltage. We are conducting the open circuit test and taking the reading. After taking and reading, we will calculate the equivalent circuit parameter. We will calculate the total losses of the no load losses of the transformer by conducting open circuit test, that is OC test. OC it is nothing but open circuit test. Now see here, the secondary winding of the transformer, in that we are keeping open, that means there is a no load on the secondary side, and the voltmeter it can be connected on the secondary side to measure the induced voltage. To measure the induced voltage, we are connecting one of the voltmeter. This voltmeter measure the secondary induced voltage. As the secondary of the transformer it is open, the no load current it will be flowing from primary winding. If the no load current it will be flowing from primary winding, it will produces some of the flux. This flux it will be links with that of secondary winding. So some EMF it should be induces in the secondary winding. But due to open circuit terminal, there should be no current flowing from secondary. Getting? The value of no load current, it is very small as compared to that of full load current, as I have already told in the no load condition. Value of no load current, it is very small as compared to that of full load. So due to very less amount of current, the copper loss occur across primary winding at a no load condition. We are just neglecting, right? No, in equivalent circuit also we have neglected that. Copper loss occur only on the primary winding of the transformer, because the secondary winding it can be open, and again due to the less current we are neglecting that copper loss also. So that we can tell that by conducting OC test or the open circuit test of the transformer, we are finding the no load losses. We are finding the no load losses, right? Now The value of no load current, it is very small as compared to that of full load rated current. The copper loss occur only on the primary winding of the transformer, because the secondary winding of the transformer, it is open circuited, and the reading of wattmeter only represent the core and iron loss. So we are considering copper loss at the input side, it is negligible. So wattmeter, it is nothing but it will shows. So as I have tell, when the transformer is on no load condition, or when we are conducting OC test, at that situation, the current taken from the supply, it is only to overcome the no load losses. That means power taken from the supply, it is only to overcome the no load losses. So that means the reading shown by the wattmeter, it will show the power reading. So reading shown by the wattmeter, it will only represent the core and iron loss. That means core and iron loss, it will becomes under constant losses. So core losses of the transformer, it is same for all types of load. Core losses of the transformer, it is same for all types of load. Okay. Now see, here it is a connection diagram, it can be given. So in that connection diagram, we are using one of the variac. We are using one variac, or it may be one auto transformer, to gradually vary the supply voltage and put it to the rated value. Then one of the wattmeter is required to measure the input power at no load condition, input at no load. One of the ammeter, it can be required to measure the no load current I0, and one of the voltmeter, it can be required, which is connected in parallel with that of primary winding, so to measure the no load voltage V. And the secondary side, it can be kept open, or instead of keeping open, we are connecting one of the voltmeter to measure the secondary voltage. To measure the secondary voltage, induced EMF or induced voltage, we are connecting one voltmeter. But load, it is not connected. That means current flowing from the secondary side, it is equals to 0. I2, it will be 0, right? So this test, it can be conducted. Now after conduction of test, which quantity we are observing? कोणत्या quantity reading घेणार आपण? Which quantity? Which reading it can be taken? काय काय कनेक्ट केलेलं आहे याच्यामध्ये? We will move through the calculation part, so that I am asking regarding that. Reading, it can be, once the test, it can be carried out, which reading it can be obtained? See, voltmeter, it can be connected, that means supply voltage V, it can be obtained. One ammeter, it can be connected to the primary winding, so no load current, it will be obtained. One wattmeter, it can be connected, so wattmeter shows some no load power W0. Okay, so this reading, it can be obtained, and if we connect the secondary side voltmeter, then voltage at the secondary side, it will be obtained, right? Now, so this is the simple connection diagram to conduct the OC test. Now see, we will move through the calculation part. Okay, calculation of open circuit test. Calculation of a open circuit test. See, once we are taking the reading, that is W0, we get the reading of wattmeter, that is power, no load power, input power, supply voltage V1, and the no load current I0. So if these three readings are occur, as we know that the input power taken from the supply at no load condition, it is used for to overcome the no load losses. Which are no load losses?
Constant and variable.
Constant and
Variable.
both losses, it will be occur at no load condition. Secondary side, it is open, so there is a no current flowing from secondary side. No current flowing from secondary side, that means variable losses or copper losses on the secondary side, it should be absent, right?
Yes, sir.
Primary side, sir.
Just telling, no, on the primary side, the current taken from the transformer from the supply, it is very less as compared to that of full load current, right? So, and do you know that the variable loss, it should be depends upon current. Suppose the transformer, it will take 0.1 ampere current at no load condition, and the resistance of the transformer, it is nothing but 1 ohm. Primary winding of the transformer, it is nothing but 1 ohm. How much loss it will be occur? Ia square Ra, 0.1 square. How much? Huh? 0.1 square. How much?
0.01.
0.01. If the current, it is 0.01, if it is multiplied by value 1, how much losses? Copper loss?
0.01.
0.01. So it is very less. So we are neglecting primary side copper loss because of the at no load condition, only at no load condition. We are neglecting the copper loss at the primary side because at the no load condition, the current taken from the supply, it is very less. It is near about 1 to 10% as compared to that of rated current. If the rated current is 1 ampere, it will take 0.1 or 1%. 1% is nothing but how much? If it is rated current is nothing but 10 ampere, 1% of that is nothing but 0.1 or 1 to 10%, maximum up to 1. So that we are neglecting the primary copper losses. So the power taken at the no load condition, it is only to overcome the no load losses like as a constant losses. So constant losses, it is nothing but iron loss and core loss, right? No, so that here then the iron loss of the transformer, it can be represented म्हणजे जेवढी power दाखवली असेल, so PI, it is equals to no load power taken from the primary, no load power taken by the primary from the supply. म्हणजे जेवढी काय power घेतलेली असेल तेवढी power, it is used to overcome the no load losses. So no load losses in the sense the iron or core losses. So that's why I am writing PI is equals to W0. म्हणजे जे काय power येईल ती loss असेल. Getting? So that means by conducting open circuit test, first parameter we get, that is no load losses, is nothing but iron and core losses, or it may be iron or core loss. Getting? लक्षात आलं? Hello.
Yes, sir.
Now, if we know this value, that means we calculate, we equate this, that means we got the no load losses. Do you know that you are having the value of input power, you are having the value of V1, you are having the value of I0. So we know that the power formula, that is W0, or it may be power formula P is equals to काय formula? V1 or VI cos phi, right? बरोबर ना? Hello.
Yes, sir.
That means the W0, it is equals to supply voltage V1, no load current I0, and the no load power factor cos of phi 0. We know the value of W0, we know the value of V1, we know the value of I0. According to this value, we are able to calculate the cos of phi 0. So cos of phi 0, it is equals to W0 divided by V1 I0, right? Cos of phi 0 calculate करू शकतो आपण. Hello.
Yes, sir.
Okay, once the cos of phi 0, that means power factor at no load condition, if we have calculated, from that power factor we are able to calculate the angle also. That means we are able to calculate the phi 0 also. So phi 0, it is nothing but cos inverse of this answer. याचं जे काय आन्सर येईल त्याचा cos inverse असेल W0 divided by V1 I0. Now we know the phi 0 also, we know the cos of phi 0 also. Now see, Again, we are able to calculate the equivalent circuit parameter. Which are the equivalent circuit parameter at no load condition? No load condition चे equivalent circuit parameter.
I0.
I0 already getting from reading. By seeing the reading, we have already taken I0. Again, remaining
R0.
which one?
R01, X01.
R0, X0, no load resistance, no load reactance. So before calculating no load reactance and no load resistance, we should know the no load component of no load current. That means we know the value of IW and I mu. What is the formula for IW and I mu? काय formula IW चा आणि I mu चा? IW, it is nothing but active component or working component of no load current. What is the formula?
I0 minus I mu.
I0 minus नो लोड कंडिशन मध्ये IW चा फॉर्म्युला आपण बघितले ऑलरेडी. इन केस ऑफ ट्रान्सफॉर्मर ऑन नो लोड, फेजर डायग्राम ड्रॉ केली होती, त्याच्यावरून मी आय थिंक ट्रिग्नोमेट्रिक प्रॉपर्टी सांगितल्या होत्या. ट्रिग्नोमेट्रिक प्रॉपर्टी वरून आपण IW आणि I mu ची व्हॅल्यू कॅल्क्युलेट केली होती.
स्क्वेअर रूट मध्ये I0 minus IW I mu.
So in one equation, if the two unknown is there, how you are able to calculate the value? That means you are telling I0 square minus I mu square. Again, IW is also unknown, I mu is also unknown. You should know only you are having the value of only I0. Whether it is possible to calculate? No. What is the formula for IW? I0
cos phi.
Right. So this is the formula. I0 cos of phi 0. It is nothing but IW is equals to I0 cos of phi 0. Once we calculate the I0 cos of phi 0, that means IW, then we are able to calculate the I mu. And similarly, formula for I mu, you are having the value of I0, you are having the value of cos of phi 0. If we put the value, then you know the value of IW. What is the formula for I mu, magnetizing component?
I0 sin phi 0.
I0 sin phi 0 याच्या फक्त अपोजिट आहे. ऑलरेडी आपण फेजर डायग्राम ड्रॉ केली होती बघा. फ्लक्सची फेजर डायग्राम. phi, here it is I mu, here it is IW, and this one is the once we have drawn here parallelogram, or it may be rectangular, we got the value of no load current I0, right? No load current I0. Here it is V1, and this I0, it is lag behind by voltage V by an angle less than 90 degrees, nothing but phi 0. This one is I mu, this one is IW. So this is the hypothesis, is nothing but I0. So sin phi, what is the sin phi or sin theta? Opposite side divided by hypothesis, right? No, याच्या opposite side कोणती? This one side is nothing but I mu. So sin phi is equals to I mu divided by hypothesis म्हणजे कर्ण, that is I0. According to this, you got the value of I mu is equals to I0 sin phi 0. Similarly, adjacent side divided by hypothesis. So adjacent side is nothing but IW. Cos phi is equals to IW divided by I0. So according to this, IW is equals to I0 cos of phi 0. बघा लक्षात ठेवा. See, once you are calculating the IW, and again you know the value of 50. So value from the value of 50, you are able to calculate the sine of phi. And once you calculate the sine of 50, again you are able to calculate the I mu. Okay, I mu. Now, after calculating the component of no load current, that is working component and magnetizing component, or we can call it as the active component and magnetizing component, then we are able to calculate the equivalent circuit, that is equivalent resistance and equivalent reactance. That means R0 and X0. What is the formula for R0? R is nothing but equivalent circuit मध्ये R असा आहे, here it is X. याच्यामधून फ्लो होणारा करंट IW, याच्यामधून फ्लो होणारा करंट I mu, आणि हे पॅरलल आहे सप्लाय व्होल्टेज. काय येईल फॉर्म्युला सांगा बरं. इक्वल सर्किट मध्ये बघितले आपण हे R0, here it is X0. What is the formula? What is Ohm's law? काय असतो ओम्स लॉ इक्वेशन?
V upon IW.
V upon I. So R is equals to V upon I. You people know the value of V. Parallel मध्ये voltage same राहील ना इथलं. So voltage V and याच्यामधून फ्लो होणारा करंट IW. So that R0 it is equals to V, that is supply voltage V1. You are having the value V1 divided by current flowing from that is nothing but IW. And similarly X0 it is equals to supply voltage V1 and the current flowing from that is nothing but I mu. So these are the equivalent parameter. It can be calculated by conducting a test, that is open circuit test. Okay. I hope you all are understood. We want to perform this experiment also. We want to conduct that test also. After conducting test, that means no need to again explain the calculation part. You people, I think all of you understood. That means at the time of conduction of practical, you are easily answerable, right? We will conduct this practical in the next practical time. That means you will better understand the concept related to OC and SC. Getting?
Yes, sir.
So these are the calculation part after conduction of OC and ESC test. This diagram, no load condition we have already discussed. Okay. Now, next one test, it is nothing but short circuit test. What is meant by short circuit test? It is nothing but on the secondary side of the transformer, there is a short circuited terminal, or the secondary terminal of the transformer, it can be directly short circuited. What will happen when the secondary terminal, it can be short circuited? काय will secondary terminal जे आहेत secondary side चे ते short circuit केले. Suppose I am drawing diagram here. This one is the primary winding. Here it is somewhat supply, it can be provided. Here it is, this one is the secondary winding, and there is these two terminal, it can be directly short circuited by using a rigid wire, or it may be rigid conductor. What will happen when the terminals are short circuited? Whether the current flowing from that terminal is nothing but zero, or the voltage across that two terminal is equals to zero. शॉर्ट सर्किटेड टर्मिनलच्या अक्रॉसचं व्होल्टेज 0 असतं का करंट 0 असतो?
Voltage 0.
That means V is equals to 0 Short circuit is nothing but maximum current it will be flowing from that. There is a no opposition, so that this terminal is nothing but short circuited terminal. So these two terminal are short circuited by using a rigid conductor, or it may be rigid wire. So see, at that situation, the current flowing from primary as well as current flowing from secondary, that means a full load current it will be flowing from primary and secondary. If we apply the full load, and this current it will be flow from the primary and secondary, that is rated current it will be flowing from the primary and secondary at minimum voltage or at low voltage. So this voltage it is called as short circuit voltage. This current it is called as short circuit current, and the power occur when conducting short circuit test. This power it is called as a copper loss. And this power it is nothing but the copper loss of the transformer. Yes. Lakshay dete what I am telling? See, the short circuit test is performed to determine the below mentioned parameter. Again, the short circuit test it can be performed to calculate the copper loss occur across full load condition, and this copper loss and previously calculated no load losses. So once we calculate the total loss, we are able to calculate the efficiency of the transformer, right? लॉसेस असतील आपल्याकडे आणि इनपुट पॉवर आहे, त्याच्यावरून आपण इफिशियन्सी कॅल्क्युलेट करू शकतो. हॅलो,
Yes, sir.
once we know the losses and we know the any one of the power, either it may be output or it may be input, because we know the input power because we are giving a supply voltage. So depending upon that, if the losses and power it should know, then we are able to calculate the efficiency. So this first one effect or the first one parameter it can be determined by conducting OC and SC test, and the second one point by conducting short circuit test is that to find out the equivalent circuit parameter, right? Which are the equivalent circuit parameter? It is to be find out by conducting SC test. In that, equivalent resistance, equivalent reactance, and equivalent impedance. That means just we have already discussed regarding that. We are able to calculate R01 or it may be R02. We are able to calculate X01 or X02, and we are able to calculate Z01 and Z02. Refer to any one of the side, right? That means equivalent circuit parameter it can be obtained by conducting SC test. So equivalent circuit parameter, equivalent resistance at load condition, equivalent reactance at load condition, equivalent impedance at load condition. That means by performing the short circuit test, these two parameter or these two following point of parameter it can be obtained. That is copper loss, and once the copper loss and no load losses it can be known, then we are able to calculate efficiency. And if equivalent resistance, reactance, and impedance it can be calculated by performing a short circuit test. Again, the connection it is similar to that of open circuit test, but instead of open circuiting secondary terminal, we are just connecting one rigid wire across the secondary terminal. Okay, see, for that I will show the diagram also. See, the short circuit test is performed on the secondary. Short circuit test it is performed on the secondary. Short circuit test it can be performed on the secondary or high voltage winding. This is one MCQ question. All of you underline this question, or it may be all of you write this question. The short circuit test it can be performed on the secondary or high voltage side. Which is the high voltage side? On that side we are conducting short circuit test, and opposite to that, open circuit test it can be conducted on low voltage side or low voltage winding. Okay, low voltage winding of the high voltage winding of the transformer, there is a short circuit test, it can be conducted. And low voltage winding of the transformer or the primary winding of the transformer, there should be open circuit test, it can be conducted. Now see, again similar measuring instrument it can be required. Voltmeter is required to measure the short circuited voltage. One ammeter it can be required to measure the short circuited current, and one of the wattmeter it can be required to measure the power taken at the short circuit test. So see, there is a requirement of wattmeter, voltmeter and ammeter, which are connected on the high voltage winding. High voltage winding, which are connected on the high voltage winding of the transformer. There, their primary winding, or we can call it as a low voltage winding, it can be short circuited with the help of one thick wire or thick strip, or we are directly connecting one ammeter which is connected to its terminal. And the low voltage source it can be connected or by gradually varying the supply voltage, or by gradually varying the voltage by using a variac. So we are vary or we are increasing the voltage till the ammeter shows a full load current flowing from winding. आपण त्या कंडिशन पर्यंतच वॅरॅक व्हॅरी करणार किंवा ऑटो ट्रान्सफॉर्मर व्हॅरी करणार up to the current flowing from that winding, it is nothing but full load current. At that situation, this voltage it is obtained, it is nothing but short circuited voltage. The low voltage source is connected across the secondary, because of which the full load current flows from the both the secondary and the primary winding of the transformer. And the full load current is measured by the ammeter and across their secondary winding. So diagram for that, it is nothing but shown in figure. This is the one of the ammeter, sorry, this is one of the variac or auto transformer. One ammeter, it can be connected in series with that winding. Again, one of the wattmeter, it can be connected. So this W, it is measured to measure the copper loss, PCU. One voltmeter, it can be used to measure the short circuited voltage, VSC. So we are varying the voltage in such a way that the current flowing from this winding, या वाइंडिंग मधून फ्लो होणारा करंट सेकंडरी साइड फक्त काय केले बघा, शॉर्ट सर्किट केले एका रिजिड कंडक्टर. करंट फ्लोइंग फ्रॉम दिस वाइंडिंग, it is nothing but it is the rated current, and this rated current it will be flow at minimum voltage. So because there is a short circuited terminal, so this minimum voltage it is called as short circuited voltage. And the iron loss of the transformer depends upon the flux. It is less occur in the short circuit test, okay, because of the low value of flux. The reading of the wattmeter only determine the copper loss. Reading of the wattmeter, it will only determine the copper loss occurred in their winding. So the voltmeter measures the voltage applied to their high voltage winding, right? High voltage side la apan kiti voltage apply kartoy. So this voltage it can be measured by voltmeter, or this voltage it is called as short circuit voltage. And the secondary current induces in the transformer because of the applied voltage. Due to that applied voltage, there should be secondary current. It should be induces. It should be induces in the transformer due to that applied voltage. Due to that applied voltage. And once we calculated the copper loss, you should know the reading of ammeter, that is short circuit current. You should know the reading of voltmeter, that is short circuit voltage. You should know the reading of copper loss. So according to this, we are able to calculate the equivalent resistance, equivalent reactance, and equivalent impedance. So do you know that the formula for that? It is nothing but, so calculation part is there. So in the calculation part, we are getting the reading. We are getting the reading of wattmeter. We are getting the reading of voltage. We are getting the reading of short circuited current. So according to this, do you know that these are the copper loss? PCU is nothing but reading shown by wattmeter. वॅटमीटरनं दाखवलेलं रिडिंग जे असेल ते कॉपर लॉस असते. ओके, नाउ वी नो द फॉर्म्युला दॅट इज copper loss PCU, it is equals to current flowing from that I square into resistance R. So according to this, you are able to calculate the R01, it is equals to PCU divided by I square. And again, you know the value of V and I. So do you know you are able to calculate the Z01 is nothing but short circuited voltage VSC divided by short circuited current ISC. And once Z and R you know, then you are able to calculate the X01 or X equivalent resistance referred to secondary or primary. Instead of representing one, you are able to represent the X02 depending upon referred side, which side we are referring. So it is calculated by under root of Z equivalent square minus R equivalent square. So according to this, you are able to calculate this R01 or R02, X01 or X02, Z01 or Z02. Okay, so this is related to short circuit test. We are performing same on the we will perform the test of OC and SC in our laboratory. Okay, so in this way we will conclude this today's lecture and we will stop here. All of you getting this testing of the transformer? Is there any doubt? Hello?
No, sir.